So let's discuss question number 33 from test 5. This is from the maximum torque. Okay, so this is from machine design of shafts. So maximum torque that should be applied to a shaft. You have a shaft. We want to apply torsion. Okay, the dia is 200 mm. If the permissible angle of twist max is 1 degree, so if I convert that in radians, it is pi by 180. So pi by 180 in a length of 5 meters. So the length is 5 meters, and the permissible shear, so tau max is 45 MPa, and take the modulus of rigidity 0.8. So G is given as 0.8 into 10 power 5 Newton per mm square, that is MPa. Okay, so now what is the maximum torque? So you have a limitation on theta, you have a limitation on shear stress. So if you recall the torsion equation, it's T by J is tau by R is G theta by L. So if I consider first two terms, the torque which I get will be just satisfying the shear stress limit, that is tau max. So let's calculate that tau max. So the torque has to be less than this, right? Okay, the torque is this. Now the torque, let's write tau is tau J by R. Now if I apply a torque which is less than the one that causes tau max, then that torque is safe, right? Okay, so the torque from this limitation is the one that causes tau max J by R. So the actual torque or the safe torque should be less than the one which causes it tau max. So this is the thing. So this is tau max for this is 45 MPa. J is your polar area moment of inertia, so pi by 32 T power 4 by R is T by 2. It's a solid shaft, right? So let's find out this. 45 into pi by 32, D is 200 power 4 by 200 by 2. So this value comes out to be 70.685 kilo Newton meter. So this is the value. The torque has to be less than this. This is purely from stress requirement. Now from the angle requirement, we need to take the first and the third term. The torque has to be less than G theta max J by L. So G is given as 0.8 into 10 power 5 MPa. Theta max is 1 degree, so pi by 180. J is again pi by 32 into D power 4, that is 200 power 4. The length is 5 meters, so 5 into 1000. So I'm converting force units in Newton, length units all in mm, stress units in MPa, so that will be all useful. So this value comes out to be 43. So remember this is 1 degree, so 43.86 kilo Newton meter is the torque. So torque has to be less than this, torque has to be less than this. So now from this, obviously the torque has to be the minimum of these two is something which will keep both the stress and the, because if I apply 70, my angle of twist has to be more. So if I apply 70, angle of twist will go beyond 1 degree, so that will fail. But if I apply 43, angle of twist will be just 1 degree, as well as the stress will be less than, because torque is proportional to stress, torque is proportional to theta, so stress will be less than 45 MPa, so both will be in safe. So this is the answer, not 70. So 43.86 is the answer. Answer is B. This is a good problem.